Thanks everyone for joining us. We'll start in right around 11:02, let's say, to let some others trickle in. Okay, so Miller might be okay, he's back now. And Hyla, maybe we can start recording.
We are recording.
Oh, perfect. Okay. Hi, everybody. Welcome to this next installment of our social impact seminar series hosted here at Harvard CRCS, the Center for Research on Computation and Society. My name is Lily Xu, and I'm a PhD student here at Harvard working with Milind Tambe. I'm very excited to co-organize a seminar series with Kai Wang, who is operating our in-person branch at the Harvard SCC. So you'll see some other people tune in person from that room. I wanted to give Milind a little chance to welcome everyone to the center.
Well, welcome everybody to the Harvard CRCS. We call it CRCS, Center for Research on Computation and Society seminar series. And we are absolutely thrilled today to have Joshua Blumenstock presenting. And we hope that soon this will all be in person, but for now we are virtual. And I'm really delighted to see all of you continuing to be present in our seminar as the audience. If you have any suggestions for who to invite in the topic of the mission of the center, which is use of computation for public health and conservation, please do send an email or message Lily and Kai, who have been organizing this seminar, for which we thank them. Well, thank you. I'll keep this brief. Over to you, Lily.
And on the topic of wonderful speakers, I also wanted to highlight that I just saw Professor Hamza Bastani from the University of Pennsylvania join in the audience. And Professor Bastani was our first speaker of the semester. And she gave a really wonderful talk on their work deploying reinforcement learning algorithm on the Greek border for COVID testing in 2020. So if you haven't seen that, check it out. There's a YouTube recording available. And on that note, I'll also mention that this talk is being live streamed on YouTube, and the recording will be left up. So if you present yourself on video and speak, then you too will appear on a recording. So just as a heads up. But without further ado, I wanted to introduce our speaker today, Professor Joshua Blumenstock, who is a Chancellor's Associate Professor at the UC Berkeley School of Information and the Goldman School of Public Policy. He's the Director of the Data Intensive Development Lab and Co-Director of the Center for Effective Global Action. Blumenstock does research at the intersection of machine learning and empirical economics and focuses on using novel data and methods to understand the causes and consequences of global poverty to improve the lives of disadvantaged people around the world. He has a PhD in information science and a master's in economics from Berkeley and bachelor's in computer science and physics from Wesleyan. He is the recipient of awards including the NSF Career Award, Intel Faculty Early Career Honor, and the UC Berkeley Chancellor's Award for Public Service. His work has appeared in general interest journals including Science, Nature, PNAS, as well as top econ journals and computer science conferences. So we're very honored to have Professor Blumenstock here with us today. Over to you.
Great. Thanks so much for the kind introduction. and also for inviting me here, and to all of you for joining in these virtual circumstances. Can I just get a confirmation that you can see my screen and hear me okay? Great. And I guess, you know, I'm very comfortable being interrupted. So if people have questions or whatever, just feel free to unmute yourselves or raise your Zoom hand. But if I'm not noticing your Zoom hands, you know, maybe Lily or Milind, you can interrupt me and just draw my attention to it. Likewise for the chat, I've learned from teaching that I am not always good at catching chat messages, or if I am, then I sort of often don't process them fast enough. So probably better to just raise your hand or speak a question. That said, what I'm going to talk about today is I'm going to focus on one project that has been going on in Togo for the last couple of years, but I'll more generally try and speak to this question about whether mobile phone data, satellite data, machine learning, basically new data and new methods that aren't traditionally used in the study of global poverty, if they can help for this specific application of targeting humanitarian assistance. So like I said, I'm going to focus on this project that is joint with Emily Aiken and Suzanne Bellou, who are PhD students. Emily's here with me at UC Berkeley. Suzanne's at the University of Mannheim, as well as Dean Carlin and Chris Udry, who are faculty in the Department of Economics at Northwestern University. So I want to just start with a little bit of context, because I know everyone's aware that the COVID pandemic has been disruptive to life everywhere. What's a little bit different is how devastating the consequences have been in low and middle income countries. So if you step back a little bit and talking about this graph on the left, you know, for the last 2 to 3 decades, there's been a steady decline in global extreme poverty. And then right when the pandemic arrived, you see this really sharp uptick. And so the most recent estimates I've seen put around 100 million new global extreme poor. So this is a pretty big change in the quality of life for a lot of people in some of the world's poorest countries. Now, that's sort of the specter. On the other side, there's been a really massive and coordinated humanitarian response. So over 3,300 new targeted assistance programs launched, and I'll talk a little bit more about what I mean by that in a second. But in terms of footprint of these programs, they're helping around 20% of the world's population is benefiting from one of these programs. I think the total budget is over $1.5 trillion. So, you know, this is a massive response. But, and this is what I'm going to focus on for the next 30, 35 minutes, is what I'll refer to as the targeting question, or the targeting challenge, which is the question of, given finite resources, how do you determine who should receive those resources? Because every one of these 3,300 new targeted assistance programs was targeted in some way. In other words, they weren't universal basic income, universal eligibility programs where everyone in the country received some form of support. You know, in many cases, as in the program in Togo that we'll talk about, less than 10% of the population received the benefit of the program. And so this question of targeting is a question that faces every anti-poverty program, including programs like the one in the US. You're probably familiar with the CARES Act, which was the US government's response to the stimulus package in response to the pandemic, where targeting for the CARES Act was based on income tax returns. So the way that the government did is they said, okay, anyone who in 2020 or 2021, where the household income was below some threshold, would receive some amount of a stimulus payment. And then that amount depended on your reported income and your tax returns. The real issue here is that if you look at countries like Togo, Nigeria, a very large number of countries around the world, they don't have recent reliable data on household living conditions. So in most low and middle income countries, even if the government had tax return information, it would be, relatively unreliable. So many people work in informal jobs or in subsistence agriculture. They're not actually required to pay taxes. So basically tax return information is pretty useless in a lot of these countries that were the hardest hit by the pandemic. And of course, in the middle of the pandemic, especially early on, when you're trying to minimize face-to-face contact, it was just inconceivable to imagine going out and mobilizing a nationwide census or survey to collect the information that you would then use to make decisions about eligibility for these aid programs. And this table on the bottom right is really just highlighting how long it's been in some of these countries since the census was conducted. So this is the issue, right? You have a crisis. You want to help people in the crisis. You potentially have money to help those people, but you don't know who needs that money the most. And so what I'm going to talk about, the main result is actually the title of this paper that came out last week, which is that mobile phone data and machine learning can improve the targeting of humanitarian assistance. Now, the choice of the word "can" is very important. It's not will, in certain circumstances, it can improve the targeting. In other circumstances, it won't. And so I'll talk a bit more about that. I won't spend a lot of time talking about related academic work. I'll just briefly highlight that this line of inquiry really straddles two very well-established literatures. One is in economics, and particularly development economics, which it has for several decades, people have studied this question of targeting and asked, how do you determine eligibility for anti-poverty programs? And there's a lot of canonical approaches out there. Community-based targeting, where you delegate authority to the community, is a very popular approach right now. Probably the most common approach is proxy means tests, where you recognize that it's going to be all but impossible to really figure out in detail the living conditions of each household. Instead, you use a proxy assessment of their living conditions by having the household answer 10 or 15 questions about, like, how big is the household? How many, what's the roofing material, right? So these things that are very highly correlated with wealth or poverty. And then you use something like a regression or principal component analysis to figure out, based on that proxy means test, how much that household is in need of support, right? So this is, again, a traditional literature in economics. And then the other literature that is brought in here is a more computer science oriented literature that has really grown in prominence over the last 5 to 10 years, which are showing how new data sources, and in particular data from satellites and mobile phone networks, but there's also work that uses data from Twitter or social media, Instagram, whatever, that are showing how these new sources of data, when processed with different variations of machine learning algorithms, can be used to measure socioeconomic status. So I'll talk more about this in a second, but just to give you a heads up that this work is sort of trying to synthesize these two very different intellectual traditions. So it's just a little bit of a roadmap for where we're headed right now. What I'm going to do is talk a little bit at a high level about the Novisi program in Togo, just so we can fix ideas on one very specific application, one particular context. I think it'll help make sense of what follows. Then I'm going to spend some time talking about these two methods that sort of exist in the literature that are saying, okay, how do we measure poverty or socioeconomic status using these non-traditional data sources? And then I'll focus on really what's at the heart of the most recent paper, which is to say, okay, if we try and design a system like an anti-poverty program based on these methods, how well does it work? And so what happened is we actually used these methods in collaboration with the government of Togo, as well as this nonprofit organization, Give Directly, to provide transfers to about 150,000 households in Togo. And so we have some quantitative results that evaluate and assess how well that performed in providing benefits to the poorest people in the country. And then towards the end, I'll open it up for a broader discussion. I'm mostly going to focus on sort of the technical details, like the technical quote unquote solutions. And, floating beneath the surface, there's a lot of really important questions about ethics and privacy, exclusion, and other topics that we can spend a little bit more time focused on towards the end. I'll mention some of these in passing as we go through the first sections of this talk, but I want to make sure there's time at the end to talk about this. I see the chat link. Okay, good. Nothing I have to pay attention to. All right, so the Novisi program. So the Novisi program, Novisi is a local, the Ewe language in Togo, it means solidarity. It's the name of the flagship anti-poverty program that is sort of run and managed by the government of Togo. So Togo, I'll have a map of this in a second, is a very small country in West Africa, sort of near Ghana, and about 10 million people, about 6 million adults, and it's one of the world's poorest countries. Over half the population is living below the international poverty line. So in Togo, this was sort of the Togolese experience of the pandemic. So there were no real documented cases until about March of 2020. So, rewind about 2 years in your mind. The first cases appeared in March of 2020. And as with a lot of countries, what the Togolese government did is they pretty quickly implemented lockdown orders that basically stopped people from working during the day and from traveling around. And when they did this, they realized that, when you have such a large population living at or below or just above subsistence levels, when you stop them from working, right, there's not a strong social safety net. And so that pretty quickly translates into hunger and food insecurity, and it starts to have much more severe, very severe consequences. And so what they did is they recognized the fact that they needed to put cash in the hands of all of these people who had to stop working, because they didn't want people to face this choice of, do I work and violate the government mandate against travel and being outside, or do I not work and just not have a way to put food on the table? So they launched this program called Novisi to provide cash transfers to basically the urban poor. And the program was designed to provide biweekly payments of about $10. So this is about half of the subsistence level required in Togo. And what was really innovative about this program is that it was 100% digital. In other words, they used mobile money. And I don't know if this audience is familiar with mobile money, but it's a very common system for conducting very basic financial transactions in a lot of African countries, as well as the Asian countries in South America, but it's especially prominent in sub-Saharan Africa. We don't really have an equivalent in the United States or in Western Europe, because in the United States, we use Venmo and PayPal and credit cards and normal banks. What's going on in rural Togo is that there are no banks. No one has formal bank accounts, but almost everyone has a mobile phone. And I'll talk about how many people exactly have a mobile phone in a second. But a lot of people have mobile phones. And what the phone companies do is they provide these systems that allow people to send and receive money using their mobile phone. So think of the mobile phone as like basically a debit card that allows people to receive money. They can do basic payments. They can cash out by going to a local agent. And if you have money on your phone, you can turn it into cash. So the government used this mobile money system to pay people these payments of about $10 every 2 weeks. And they set up a USSD-based registration system. And this, again, was part of the motivation, was they didn't want a lot of face-to-face contact when they were distributing humanitarian aid. It was also a much faster and cheaper way to get money out all over the country using these digital systems. Oh, sorry, I have this video. I'm not sure if it comes through well on Zoom. It's not that important. This is sort of, you can see how the government is promoting awareness around this program as a way to get money from the government to the people. You can go to novisi.pg if you want to learn more about the program. It's still in operation. I will just briefly highlight this because I think it's really important as contextual information, and we can come back to it later. We did a lot of analysis using survey data from Togo to characterize access to mobile phones and mobile money. And so what this is showing you is sort of geographic penetration of mobile phones. And here we're seeing demographic at the individual level and household level. And just to sort of put these graphs and numbers, what you see is that while roughly 65% of individuals own a mobile phone, about 85% of households have one or more phones. And that's because it's very common for a rural household to just have one phone that's shared amongst the family. There's an important issue of right now I'm still in background mode. Nothing I'm telling you right now is anything that we've done. Like the program that the government launched, we had nothing to do with. But they were interested when we first started working with them in having a better understanding of who was being able to access the program's benefits. So one thing they did that I think was pretty clever, and sort of keep this in your mind, is they linked registration for the Novici program to a SIM card, not a mobile phone. So in other words, if you're a household that has one mobile phone, you could potentially have 2 SIM cards registering for the Novici program by putting the SIM card into the phone. A SIM card's very cheap, whereas a mobile phone is relatively expensive. So if you're interested, we can talk more about SIM card phone penetration and so forth. But a very high percentage of individuals in Togo have a SIM card.
A quick question from the audience. So Apara Marathe asked, when you're talking about mobile money, has this mobile money system been around for a while, or did the usage increase during the pandemic?
Great, thanks, Lily, and thanks, Prajita. The mobile money system has been around for a while, but usage increased dramatically during the pandemic. And I actually have a PhD student, his name is Suraj Nair, who is writing a paper on that exact topic, which is to what extent did the massive distribution of cash payments through mobile money lead to immediate but also sustained use of the mobile money ecosystem. So if you're really interested, I can put you in contact with him. He has like a draft of the paper, but it's not been submitted anywhere yet. The short answer is that there was a very sudden and sharp increase in mobile money, like registrations and also active users. And then, once the cash payments stopped, mobile money use decreased substantially again, but it's much higher than previously. So there was an uptick in sustained use of the mobile money ecosystem caused by this cash transfer program. So it's a good question. Okay, so this is a challenge. This, again, the targeting challenge that I mentioned a couple slides ago. How did the government determine eligibility for Novici? The issue in Togo, so again, being more specific rather than general, is that there was no comprehensive social registry. There were no tax returns. There was no recent census. The most recent census in 2011 was 10 years old, and it didn't even have the information you would want to target an anti-poverty program. So what they did was they decided that they would basically target on 2 dimensions. One was geography. So they wanted to prioritize urban areas, and 2 was based on occupation. So they wanted to prioritize people working in informal jobs. And how did they do this? Well, they were really resourceful in that they said, well, we don't have a registry. Like, they were actually planning to do a census in 2020, and then the pandemic upset those plans. So that's sort of like the worst case scenario, that the data was as out of date as it possibly could have been. But there had been a nationwide election in early 2020, just before the pandemic arrived, and in the process of getting ready for that election, they had updated their voter registry. So their estimates are that about 80 to 90% of adults were registered to vote. And in the voter registry, people indicated their home location, basically to get to their nearest polling center. And they also self-declared their occupation. Basically, they hand wrote in what they said they did. And it was a whole mess to figure out how to reconcile those thousands of different handwritten occupations into a list of what is formal and what is informal. But the government's rationale was that, well, when you put in place these lockdown orders in urban areas, that stops people from working, and it's the informal workers that are hardest hit, so let's get them paid. Okay. So what we did is we looked at nationally representative household survey data and basically, helped them answer the question, how well did this program, this targeting approach of informal urban workers, perform at reaching the poor? And what we see in urban areas is that, so this is the consumption distribution, that the informal workers were actually roughly equivalent, like a little bit tighter distribution, but roughly centered around the same mean and median values in terms of overall consumption. And I should say, in low and middle income countries, consumption is sort of the gold standard measure of living standards, right? And consumption is a measure of roughly per day, how much is an individual consuming, right? And the total like dollar value of, because that could be, wheat and corn that they've grown on their house, as well as stuff that they're being given from a friend. It's like the total value of consumption and expenditures per day per person. Okay, so this is actually fine. This is maybe not good news, not bad news. The real issue was when we look at rural households, we see that this approach to targeting is actually very ineffective at reaching the poor. So what you see here is that people in informal jobs are actually consuming more than people in formal jobs. And that might be a little counterintuitive but it's because of what I said earlier, that everyone in rural areas is essentially working in informal jobs or subsistence agriculture. So the people who are working in formal jobs are, in a sense, more outliers. So looking at the data, as the government thought about how to expand the program into rural areas, they were immediately aware that it didn't make sense to extend the approach that was used in urban areas of using the voter registry and targeting based on location and occupation. Okay, so that's sort of the context. There's going to be these two methodological shallow deep dives. The first is on this geographic issue, and I'm going to go over this pretty quickly, but I'll just show you the intuition, and then if you're interested, we can talk about it maybe towards the end, or interrupt me and I can provide you more details. The idea here is that when the government wants to, here's a map of Togo, your first map of Togo, I should have showed it earlier. Most of the urban population is concentrated in the south, in the area of Greater Lomé. There's also a urban area up here, and also semi-urban up here. But the government was really interested in expanding to the poorest rural areas, right? So they had finite resources. They said, all right, we want to geographically prioritize those villages and counties that are the poorest. The problem was, even at that level, they didn't have the data that would allow them to make that decision. So there was no existing data set in Togo that provided even prefecture, but also canton representative estimates of poverty. So this map is showing you all the cantons of Togo, where you can think of a canton as roughly like a county, like a set of a few villages. So in the most recent survey in Togo, less than half of the cantons had any households that were surveyed, okay? And so this was a problem. This is not a problem that's unique to Togo. This is a problem that faces a lot of developing countries. And you can see some sort of statistics here. Only half of the poorest countries have completed a census in the past 10 years. So what did we do? This is sort of like the schematic slide. I have another slide that tells you exactly how we did it, but I'll skip that slide unless people ask questions. The idea here is pretty simple. Like, the intuition is that if you're looking at high resolution satellite imagery like this here, poor villages look different from wealthy villages, right? They have different quality roofs. They have different housing density. They have different quality roads. There's like different types of urban design, urban planning, like the layout of houses and amenities is very different in wealthy areas than it is in poor areas. And if a trained human looks at these images, they can roughly tell you, rank these villages on a spectrum of most wealthy to least wealthy. And just like a human can do that, so can a supervised learning algorithm. And so machine learning algorithms, I think I'm preaching to the choir here. I think you probably know a lot about these, but they're very sophisticated technologies for pattern recognition. And so what we do is we collect very, reliable labels for a large number of locations in Togo of the ground truth wealth of the village or the household. We match that to high resolution satellite imagery. We use like convolutional neural nets as feature extractors from these satellite images, and we pass these into supervised learning algorithms that then say, okay, how well can we predict for coordinate X, Y, the wealth of the households living in that catchment area based on satellite imagery from those particular coordinates. And so at the end of the day, what you build is a trained model that predicts from high resolution imagery the living standards of the people in those pixels from the satellite image. And so this is showing you that high resolution poverty map derived from satellite imagery. And from this, we can get to estimates of the average or median wealth of households in each canton or prefecture or whatever geographic unit we're interested in. We can also provide estimates of the poverty rate of different geographic units. And so the mandate coming from the government of Togo was to help them identify the 100 poorest cantons in the country. And so basically to solve this problem, we use this approach right here. Again, I can talk about the details if people are interested. I have some slides that sort of talk about the data that we use to train some of the models, but I'm going to sort of skip that right now unless there are questions, just because I want to make sure to get to what I think is the real core of this talk, which is how we then use mobile phone data. I'll just briefly show you on this slide. What we do on the right is we compare for the regions of the country that have surveys. This is a subset of all of the regions of the country. We compare the survey-based estimate of wealth, that's what's being plotted on the x-axis, to the predicted wealth based on satellite imagery. And we see that there's a pretty strong correlation. So this is reassuring. This is telling us in basically the non-gray areas on this map, where we have some sense based on surveys of how wealthy the people are, that in those areas, when we match those estimates to our satellite-based estimates, that the correlation is pretty strong. And so what that allows us to do is that gives us increased confidence in the accuracy of these estimates in the gray areas, where there is no other way to measure the living standards of those households. I see there are some questions in the chat. Lily, do you want to help me out here, or should I read them?
Most recent, so Laura asked the question from the last slide, which is one that I also had. Is the assumption here that the cantons are pretty uniform wealth-wise?
Oh, no, absolutely. Oh, you mean within a canton? So there's two questions. One is the distribution of wealth across cantons uniform? And the answer to that is absolutely not. That's exactly the problem we're trying to solve, is that we assume that there's a lot of heterogeneity in wealth geographically, and so we then want to target, based on that. And then, I think what at least is your question, Lily, is that within a canton, do we assume that every household is equally wealthy? Absolutely not. Right. So we can have different moments we can estimate different moments of the wealth or poverty distribution, like the median or the mean or the standard deviation, or the percentage of households living below the first decile of the wealth distribution. It just so happened that what the government cared about was which 100 cantons have like the lowest average living standards. So for this particular application, we were solving for like the average, so that moment of the wealth distribution. But when it comes to targeting, and this is actually a huge motivation for going beyond just geographic targeting, is the recognition that within the poorest cantons, there are some ultra poor people, and then there are some not so poor people. And so, one thing the government was considering, and this is actually one thing I was going to talk about later, I'll just talk about it now, is for a lot of very good reasons, they were skeptical about using data from mobile phone companies to make decisions about targeting and distributing aid. And so they were wondering, well, what if instead of targeting the 100 poorest cantons, we just targeted like the 5 poorest cantons and gave everyone in those 5 poorest cantons access to the program, right? How does that look compared to a program that starts with the 100 poorest cantons, but then only provides benefits to the 10% poorest people in those 100 poorest cantons? So these are policy decisions, I think, and I'll have something to say about how effective those two approaches are. But for exactly this reason, that we don't assume that everyone in a given geographic region is equal, we're then interested in using data from other sources to triangulate the poorest people within those poorest regions.
Awesome. And thanks again, Laura, for the question. So the other question by Taufik, and perhaps this is might be best saved for discussion at the end. Taufik wonders more about how the mobile money system works and if there's regulatory systems and related instruments in place.
Yeah, I think that is better deferred to the end for a more thorough discussion. I think in short, the mobile money ecosystem is regulated by the government. In different countries, it's different branches of the government that do it, whether it's the financial regulator or the telco regulator or some other regulator. In Togo, the mobile money operators work very closely with the government regulatory agency to make this program work. So there were a couple of things that were actually a little bit unusual in Togo, which is that they made it possible for people to basically fast track some of the normal registration steps. So typically, when you register for a mobile money account, you have to appear in person and present some form of identification, basically for identity verification. What they allowed with Novisi was for people to auto-register, basically to link a mobile money account to a national ID without appearing in person under these sort of exigent circumstances rationale. But there's a lot of details and nuance, and I think the specific approach and taken in Togo may not generalize to other countries, but I think it is a relevant question.
And maybe a quick one from Yiping Huang now. In validation, do the 2017 and 2018 surveys differ in the locations that they survey?
Yeah, definitely. So they're very different surveys, and I'm not going to talk about the details too much. I'm actually going to talk more about the 2018 survey and a 2020 survey that we did. The 2017 and 2018 surveys were both done by the government before any of us had actually set foot in Togo. So they were sort of existing data. They were meant to be nationally representative, but you can see that there are differences in the map. Like here, this canton was surveyed in 2017 and not in 2018. They had very different survey design, sample frame, and survey instruments. And so what we do in the paper is we sort of compare our estimates to both of these to see, how well they compare. And what's sort of interesting is the correlation between our estimates and either one of these surveys is roughly the same as the correlation between this survey and this survey, right? And that's because, there's a lot of noise in any survey. And so we don't expect to see a perfect correlation between 2017 and 2018. There might also be changes in living standards over time, but likewise, we don't see a perfect correlation between our estimates and either of the survey-based estimates. Okay, so second, major part of this talk is to address this question of how do you identify the poorest people within the poorest regions. And the idea here, again, is pretty simple. And the question then is, how do you translate this idea into something that can be implemented? The idea is that mobile phone data are very predictive of economic status. So I've written a few papers on this topic. Other people have written papers on this topic as well. But the intuition is just that different types of people use their phones differently. And in particular, ultra poor people use their phones differently than non-poor. And so what I'm showing you on the left here this is actually from a study in Afghanistan, the last bullet on the slide, where we basically compare the patterns of phone use of people who are in the poorest of the poor in Afghanistan to people that are not in that group. And what we see in this graph is just that ultra poor people use their phones far less frequently than non-ultra poor people. And that's one example of a metric of phone use. There are literally thousands of ways that one could quantify phone use. And across a lot of these different metrics of phone use, we see pretty stark differences between how ultra poor people are using their phones and how non-poor people are using their phones. And again, if you have all of these individual indicators, well, what a machine learning algorithm can do is it can say, okay, given all of this signal of differences in socioeconomic status, can we form an accurate prediction of the socioeconomic status of the person using that mobile phone? And so, just looking at the clock, I won't go into great detail, but the key required to unlock this method is, as it is with most supervised learning approaches, is reliable and representative training data. So essentially what you want to do, and this is a slide from our project in Afghanistan, is collect ground truth survey data that you trust. And through the survey, you can collect informed consent to access data and so forth. You conduct a ground truth survey that allows you to measure the living standards of the person that you're speaking to. At the same time, from that survey, you can measure something that I'll denote by YI, which think of it as like a single scalar value that indicates the relative wealth or the relative consumption of that individual. We can match that to data that's coming from the mobile phone. In the case of Togo, we work directly with the mobile phone operators to get access to the metadata. And then through some process, we take the metadata, engineer features out of it. And these would be things like, average number of outgoing international calls per week, or the ratio of incoming SMSs to outgoing SMSs, whatever. The sky's the limit. There's literally thousands of these features that you might think to engineer. There's a whole set of papers that are about how do you actually engineer features in a sort of systematic way. I'm going to skip that right now. You could think about doing it by hand. You could think about using representation learning. There's a lot of different interesting ways to do this. A couple of theses have been written about this exact problem. I'm going to sort of abstract away from it now, but just imagine that from the data, you can construct a vector of predictors xi. And so then for each of the individuals that you survey, you know something about their phone use and you know something about their living conditions. And then the supervised learning task is to say, okay, how well can we predict wealth given the call detail records or the mobile phone metadata X? Is that sort of clear what's going on here? And I don't think the details of the models that we use are that important. I think in practice, the model that works best in Togo was a gradient boosting machine that had about 150 features at the end of the day. Okay, here's sort of showing you the feature importances of that model. Well, if you're interested, we can talk about it, but essentially you see that all sorts of information in the mobile phone metadata is being used to form these predictions. There's a lot of geographic information, like where are the people making the calls from? There's also information about like the diurnal behavior, like the diurnal rhythm of calling, like what % of calls are made at night. Turns out to be very predictive in Togo. We also have information about mobile money transactions and so on and so forth. So at the end of the day, and this is what is more important, we see that, so this is showing you for a survey, that 2018 survey, this is a nationally representative household survey that was done in 2018. We're plotting for each of the 4,296 survey respondents that had a mobile phone. There's a dot in this figure. And so each of these dots is one of the people. We're plotting the true consumption measured from the survey. And this is like a 3.5-hour survey. It's a very long form survey where they collected the most reliable measure of consumption and expenditures that is possible, sort of like conventional wisdom suggests is the best way to measure living standards in a place like rural Togo. We're plotting that against the predicted consumption, where the prediction is based on sort of that schematic pipeline I showed you on the last slide, essentially based on how they use their phone. And so what this table is doing is it's quantifying the strength of this correlation. And what you can see is it's not perfect, right? There's a lot of noise in our prediction. There's plenty of error, but in general, there is a reasonable positive correlation between what the phone data are predicting is that individual's consumption and what their true consumption is. And there's a lot more details in this table that I won't go through. Maybe I'll just highlight a couple of things. One, it's a lot easier to predict things like wealth, asset index, or proxy means test than it is to predict consumption. Also, and this is sort of important from a policy perspective, that an alternative approach that you might think about is, well, forget all this machine learning. What if we just like looked at how much a person is spending per month on their phone bill, right? Presumably that's pretty correlated with their socioeconomic status. And so we do that and we compare that single feature prediction of socioeconomic status to the fancier machine learning approach. And there is a very substantial increase in predictive power when you use this supervised learning approach. And there's some stuff down here that I won't spend time talking about. Okay, so this is the last figure is what we found in Togo. I mentioned in passing that this is not a study that was done in isolation in Togo. Here's a series of similar figures from Rwanda, from Afghanistan, and from 2 different surveys in Togo that are basically showing you that this seems to be a pretty general phenomenon, that across contexts, mobile phone data capture between 25 and 50% of the variation in socioeconomic status. And that variation from 20.24 to 0.46 depends on a bunch of things. But I won't get into the details, but it's like, as I mentioned, it's easier to predict wealth than it is to predict consumption. It depends on the quality of the training data and other considerations. Okay, but here's where there's like a really important pivot, which is to say, okay, up until 2020, up until this project, we knew this, right? Nothing here is necessarily new. But what we didn't know is whether the predictions that you're getting from phone data are accurate enough to make targeting decisions about who should get humanitarian aid and who shouldn't. And so what this schematic is showing you is what it actually means when we say we're using phone data to make decisions about who gets cash and who doesn't. So here's that same scatter plot. I just colored it a little bit differently. The idea here is if you look on the x-axis at the true consumption, and sorry, this is scaled in the local currency now, not in dollars. The idea is you want to target people below a certain threshold, basically the poorest people, where the threshold is determined based on your budget constraint. But in practice, what you end up doing is you target based on the y-axis, right? So you want to target based on true consumption, but you don't have true consumption data. So you target based on predicted consumption. And so what's going on here? Well, the people, these dark blue dots, these are the people who are truly poor below this threshold, who are targeted because they're below the predicted threshold. So this is good. You want to maximize the number of dots in this quadrant. You also want to maximize the dots in this quadrant. These are the people that are not poor in reality and who are predicted to be not poor based on your algorithm. So the more dots in these two quadrants, the better. What we're really worried about are the people in this quadrant here. So these are the people who are actually poor. In other words, they're to the left of the vertical line, but they're predicted to be non-poor by the algorithm. In other words, they're above the horizontal line. So these are exclusion errors. And then, likewise, there are inclusion errors here. So these are the non-poor people who are actually targeted. So these are the people that need the benefits less, but get them anyways. Okay. So what I'm going to, it's important that you understand what's going on in this figure. And it's also important that you understand when you look at this figure, you might say, hey, wait a minute, there are a lot of dots up here. Isn't that a problem? And the answer is yes. Okay. But the problem is any targeting system that you deploy is going to have dots in this quadrant. And so if you're a policymaker and you're making a decision about how to design a program, the question is not, how many dots are up here? It's which method will get me the fewest dots up here and also the fewest dots down here. Okay, so what I'm going to pivot to now is the results where we actually quantify those dots for a few different approaches to targeting in Togo. So, sorry, I should have shown this earlier, a picture of a Togolese rural village. This is actually a pretty nice household. And this is a map of Togo. So you see it's between Ghana and Benin and West Africa. Here's the context. Okay, any questions before I move on? Okay, so again, the main question I know that I'm presenting the main question with only a few minutes left. That's because I think a lot of the innovation is in the methods that I've talked about already. And so at this point, some of this should be a little bit more intuitive. What I'm going to show you is I'm going to compare the effectiveness of targeting using the mobile phone based approach, number 3 in this list, to 2 other approaches that the government was considering. One was the occupation-based approach that they had already used in the urban areas. And the other was one that came up in response to Lily, and I think it was Laura's question, that they were seriously considering the idea that instead of expanding the program, to a wide geographic area, they would just give universal transfers to everyone in a few villages. So we'll compare to that. And then we're also going to compare to status quo approaches based on like the proxy means test that I mentioned earlier. Importantly, these were not feasible in Togo. So this is more just a hypothetical scenario to say, okay, in the future, how should a government or humanitarian organization think about how well this mobile phone-based approach fits into all of the different spectrum of approaches to targeting? Let me skip this timeline. It's not super important. I'm also going to skip the details of the surveys to, put the main results in front of me. So this is really the key results figure, and I'll just tell you what it says. So here, what we're comparing is 4 different approaches to targeting: phone, geographic, occupation, and then an asset index. So this was not feasible. These were feasible. And then the light bars are showing you the area under the curve, which, if you know what it means, great. It's sort of a threshold agnostic way to assessing the performance of the targeting mechanism. And then probably the one that's a little bit more easier to interpret for people that don't know AUC is the dark bars on the left, which are showing recall and precision, which you can think of as 1 minus the exclusion errors. So like what you're seeing here, 47% recall means that roughly 53% of the true poor were not receiving benefits if they were being targeted with the phone-based phone-based machine learning approach. Now, you may say 53% exclusion errors, that's pretty high. It is, but I'm not pretending it's not. But the problem is the other approaches are so much worse. And you might ask, okay, 67% exclusion errors under geographic targeting. Why is that so bad? Well, look, if you're targeting a program that's only available in 5 of the 100 poorest cantons, there are all those poor people in the 95 other poor cantons. And none of them they're all going to be systematically excluded from this program. So, it's a real difficult predicament that the Togolese government was in. And so what we're essentially showing in this paper is that this phone-based approach, while far from perfect, performs relatively very well. I have more details on sort of another set of results that are a little bit more nuanced. I'm going to skip these for now. This is a little bit more relevant towards like the hypothetical scenario where a government might be interested in designing a nationwide anti-poverty program using mobile phone data. And the key result there is that if the government has access to nationwide survey data, basically an up-to-date census, they should rely on that. They should not use this mobile phone approach. But as you might expect, the farther you get away from that census, the more like the lower the accuracy of the census-based approach. And it's sort of a few years down the line where the mobile phone data approach might become relevant again. I see there are another question. Let me defer those. I want to just spend 3 minutes throwing at you the other key results, and then we'll have the rest of the time for open Q&A. I think one thing that's really important that I've mentioned, but not really systematically, and this is something that we dig into a lot, is those exclusion errors. There are a lot of sources for exclusion errors. So I mentioned the exclusion errors that occur because of the algorithm, right? That 47% recall implies 53% exclusion. But the algorithm is only one source of exclusion in this program. A key exclusion is, I mentioned this already, you have to have a SIM card. And we estimate that about 85% of households have a phone. So, maybe that's not terrible. But all of these things in combination start to add up. You have to be registered to vote. And while a lot of people are registered to vote, not everyone is registered to vote. And the problem is the people who aren't registered to vote and the people who don't have a SIM card tend to be poorer on average. So you're often systematically excluding exactly the people you don't want to exclude. There's also issues of people like making the decision to actively register and succeeding in register. And that actually creates exclusions as well. And these are problems, okay? But again, we're not in like fantasy land of engineering and simulation. We're in reality land where you got to get cash to people. And the only way that the government knows how to do this is to use this mobile money ecosystem. And so some of these things are built in. So while it's not perfect, it's as good as they can do. Other things in the paper I won't talk about. We do a welfare analysis. We look at fairness. So we do sort of like an algorithmic audit to look at systematic exclusion of particular demographic subgroups. If you're interested, we can talk about those results. The bottom line is that every method for targeting that was available in Togo has some issues with bias, but it's not like the machine learning approach. It actually performs better in terms of systematic exclusion than some of the other approaches. Let me just skip this entirely. Okay, this is going to be basically my closing slide, which is to say, I think most of what I've described to you has talked about how the approach using mobile phone data and machine learning was accurate. It's pretty intuitive that this approach is also very fast and cheap relative to other things that require like, mobilizing communities, getting surveyors out into the field. And in the Togo case, we showed that it substantially improved the targeting of cash transfers. In other words, it did a more effective job of getting cash into the hands of the poorest people of the country than the other approaches that were available. And so in the end, I think the number's a little higher now. We worked with the government and this nonprofit organization to implement this approach to provide cash transfers. Some of the things I haven't really talked about, but that are very important in thinking about how this approach fits into the grand scheme of social protections and humanitarian response. There are important considerations about data access and data privacy. Some of these topics are the things that my group is working on most actively right now. Like, can you design a mobile phone-based prediction algorithm that's differentially private? And intuitively, what we find there is that if you add differential privacy into the mix, it guarantees privacy. That's great, but it also diminishes accuracy. And so the question is, how substantially does it diminish accuracy? And at that point, is it worth using that at all? And so, look, I see my role here as a researcher is not to make those decisions. Like, this is a tough decision. If you're a government, do you want a system that's using sensitive private data, but is very effective at providing transfer to the poor? Or do you want a system that's differentially private, but is less effective at providing transfers to the poor. To me, that's a policy decision. As long as we can make that logic, calculus, and those trade-offs transparent to the government, I think it's really the elected officials' job to make those decisions. I think it's my job and our job to sort of make those policy options available. Issues of reaching people without phones, informed consent. How is this top-down, centralized approach perceived by the community? How do we design a program that safeguards against future misuse? And then finally, and this is something we're really actively working on actually in Togo, is how do you look to the future when you know that this is one option, but there are other options? How can you best combine community-based targeting with phone-based targeting in a way that provides integrated, holistic social protection for a bunch of different scenarios, anti-poverty programs during normal times, as well as crisis response during pandemics. Okay, so with that said, let me just sort of put a picture. This is Emily. I think some of you have met her already. A real key driving force behind this project. Also Suzanne right here, and then a bunch of other postdocs, PhD students and research staff who have worked on the project in various ways. I mentioned Siraj. He's the guy who's working on the question of how did the program increase the use of mobile money in Togo. Contact information over here. Sorry for talking so long. Hopefully there's a few minutes for comments and questions. Lily, maybe I'll turn it back to you to help moderate.
Thanks so much, Shash. First,
Lily, before going into questions, I just wanted to thank Joshua for an excellent presentation, and maybe we can just virtually or just clap for a while, just to say thank you. Really
thank you, Malin.
Wonderful presentation. Really appreciate your taking the time to talk to us. With that, I'll hand this back to Lily.
Great, thank you.
Thank you so much. And thanks to the audience as well for the engaged questions and discussions throughout. So I will, I'm trying to filter through these, but I'll just start with one that has been kind of burning the back of my mind. So you mentioned that potential use for this is to target the bottom 10th percentile and really focus on that ultra poor, and you sort of looked at the phone usage for those ultra poor. But do you have any insight on whether those who don't have phones, sort of that second bullet point in future work, are actually the ultra poor? And perhaps there could be some work looking at the differences between satellite images, estimating population density, and discrepancies between phone usage to try to identify where those sort of missing data are.
Great. No, thanks, Lily. And also I had a chance to read Akash and Sandro's questions, so I can, some of these are related. Absolutely, right? Like I think, so practically we do have household survey data that was done in person, and we do find that people without phones are poorer than people with phones. It's not like so stark that it's like, oh, the program, like there's plenty of extremely poor people in Togo who do have phones. But exactly as you and I think Akash are pointing out, as well as the second question from Sandro, is that outside of the context of a crisis, when you have the option to, prospectively design a program, knowing the data you'll have access to in advance, I think that the real question on the floor is how do you best integrate the different data sources to make sure that no one is ever systematically excluded? And so it may be the case that if you find that there's very low rates of phone ownership in certain geographic regions, that maybe the best way, maybe you target using phone data in areas that have high penetration, and then in the areas with low penetration, you actually invest a lot in mobilizing a ground game to put people in those villages, right? I think it's a really complicated optimization problem because the government has finite resources. The more money they spend on putting people on the ground in those villages, the less money they're distributing. So I think there's actually really interesting technical questions, as well as very interesting non-technical questions. But for this audience, I think about like, how do you optimally design a program that's best using those resources, right? If you could invest $1 million in collecting household survey, great. But does that increase social welfare more than a program that used those $1 million to more noisily target? Right? It's an extra $1 million to distribute. And so all of these questions, to my knowledge, are really, no one really knows the answer. And so I think that's where a lot of the future work is headed right now.
I want to recognize that we are at the top of the hour. So if anyone in the audience has to pop off, please do so. And then Josh, if you as well need to, we would completely want to respect your time.
No, I have a few more minutes. Yeah, I'm happy to take a couple
Awesome.
questions, but anyone should feel free to drop off. Yeah.
Awesome. I think Josh sort of hit at Akash's and Sandra's questions. And let's turn it to the live audience in the SEC.
Hello, thank you very much for the presentation. I was curious if there's any difficulty during deployment on the side of the government in kind of communicating or justifying the use of these methods to the public. For instance, if it seems very hard to say you weren't admitted to this program because based on your phone usage, you can make enough calls that you're not considered poor. Or something like that. And kind of following up on that point, is there interpretability and a way to communicate the results of both the phone-based targeting and the satellite inferred both?
Yeah, no, those are excellent questions. And there certainly is some confusion. I think it's not as rife and ubiquitous as you might expect, because again, it's a very different on the ground environment where, and we've actually, so there's been a few different ways that we've tried to answer these. So before actually launching the program, there was a lot of field work in partnership with this NGO and the government to go into villages, to work with community leaders, to help make people aware of the program, and also to sort of get in front of the sort of questions that might come up. I showed you that video. There were also radio campaigns to promote awareness and basic understanding that this program was going on. And then after the fact, there was a lot of follow-up surveys. And I actually have another PhD student here at Berkeley named Zoe Khan, who's an ethnographer, doing more ethnographic, qualitative, field-based follow-up to really just, spending a few hours in one-on-one interviews to talk to people to get at community perceptions of these programs. So, it's hard to give you a very concise answer because talking to a lot of people, you see a lot of different perspectives. But I think it's a very different reaction we're seeing in Togo than if you had done this in, say, Silicon Valley, where everyone is aware of what an algorithm is, what their data are, and the potential considerations and concerns around this. I think in a place like rural Togo, even, and this is something that Zoe has discovered, just communicating the notion of data from a phone being used is pretty outside of the spectrum of things that people are used to thinking about. And so, what you see in practice is people are very happy when they get the money. They're disappointed when they don't, but there's a lot of sharing within villages as well. And so I don't think, for better or for worse, I think a dominant perception is that it's sort of like a lottery program where people understand that the government has finite resources and some people are sort of being chosen luckily. I don't think there's for better or for worse, I don't think people are oh, the government has this perfectly trained robot that's picking out the poorest people in the village. But I think, there's some recognition that it's not the wealthy village heads that are getting the money, but beyond that, it's sort of a benefit. I realize that's a very loose answer, but it's sort of what we have at this point.
That makes sense. Thank you.
Yeah.
Let's perhaps take one more question. So a second question from Sandro asks whether you've looked at creating an ensemble of using the satellite imagery estimator and phone data that you have estimated, but then also some of those other community-based approaches as well.
Yeah, so I think there's two ways to interpret Sandro's question. So the first is, and this is actually what we did. It's an ensemble in the sense that we use both geographic targeting at the canton level. And then when we do the phone-based approach, we restrict the phone-based targeting to the people in those 100 poorest cantons. Now, it might be a little counterintuitive. You might wonder if you're using phone data from the entire country, why worry about concentrating in the 100 poorest cantons? Why not target everyone in the country give them, potential eligibility? That is a great question. And in simulations, we find that would actually do a slightly better job of reaching the ultra poor because you wouldn't have that restriction. You could target like the poorest people in every canton rather than the 100 poorest canton. The reason for that was it came from the government. And I think there's actually a really smart reason, which is that to promote awareness and to increase registration for this program, you need to have sort of critical mass within communities. In other words, if only 1 out of every 100 people is eligible, then what's going to happen is people are going to pick up their phone, they're going to dial the USSD code, they're going to be denied, and then they're going to tell their neighbor, don't bother. And so what you wanted was to have sort of these network effects and adoption and registration, because for a program like this to be successful, you actually need people to register, right? Because until they register, the government is not going to know that they exist or know how their phone number matches their voter ID and some other details that I didn't talk about. Okay, so that's one answer. The other answer, and I think this is really what Sandra was asking about, is like, can you take the features from the satellite imagery, combine them with the features from the mobile phone data, and use that in a joint predictor? In theory, you could, and so, actually full stop. In theory, you could, and we didn't, and it's definitely worth looking at more carefully. Part of the reason we didn't is that the phone features are uniquely associated with the individual. And the satellite features are uniquely associated with a pixel. And it's not always, it's not obvious how you match satellite features to a phone person. Right now, we roughly know where each phone person lives based on where they register to vote and where which cell towers they're using. But it would require some assumptions and some empirical work to figure out what the best way is to match. Do you take the 100 pixels closest to the person's voting location, or do you look at the pixels around the cell phone towers they're using? So we didn't do that in practice, partly because the phone data has a lot of very rich geographic information. And so as you saw in that slide on the feature importance plot, we do use geographic information, but not of the variety that you're talking about. But I should acknowledge that I think that's a very interesting question to look at, especially if you had, say, actual GPS coordinates for individuals, because then you could do a better matching of the person's location to the satellite data.
Awesome. Thank you so much, Professor Blumenstock, for such impactful work, for sharing it with us, for staying longer to answer the many questions that have come in. Thanks to the audience for staying here. And with that, let's wrap up the session and perhaps give one more round of applause.
Great. No, thanks for hosting and for all the questions. It was really fun. So thank you.
All right. Please stay tuned with our future talks on coming Mondays. Thanks so much, everyone.